My name's Chris Bianchini, and I chose to do my project on the British Airways Concorde. So the Concorde was a British-French turbojet-powered supersonic passenger airliner that operated until 2003. It had a maximum speed of Mach 2.04, which is 1,354 miles per hour, and it did this while also seating 128 passengers, so pretty impressive speed for such a large passenger airplane. It was one of only two supersonic transports to have been operated commercially, the other being the Soviet Tupolev Tu-144 that operated until the late 1970s. One major perk of this airline is that it could fly major routes in less than half the time it took other planes to do the same route. In terms of performance, it was optimized for high-speed flight. It had double delta-shaped wings, as you can see in the pictures. It also had a variable engine air intake ramp system, which meant that the performance of the engines could be varied manually, depending on performance needs. Also had thrust-by-wire engines, meaning that computers could control exactly how the engines were performing rather than any sort of manual system. It also included a droop nose for landing visibility. As you can see in the background here, that the nose is a little bit tipped downwards. It also included a super cruise capability, meaning that it would be able to travel at supersonic speeds without consuming as much fuel as would be expected. There's also a lot of weight saving and enhanced performance measures. They used a high temperature aluminum alloy to build the plane, so it's super light and really resistant to high temperatures as you would need traveling at supersonic speed. Obviously the skin friction drag is going to be a lot higher than at lower speeds. It also included a pitch trim control system by shifting fuel fore and aft to control the center of gravity, so the operator could shift the fuel forward and backward in order to control where the center of gravity was located. It also was one of the first planes to include a complex air data computer for automated monitoring and systems adjusting based on aerodynamic measurements. This plane doesn't fly anymore, and there's a lot of reasons for that. The primary reason is that this plane was pretty much only used by wealthy passengers. So, for example, in 1997, a round-trip ticket from New York to London was almost $8,000. So people wanted to go faster, but they didn't necessarily want to go $8,000 faster. The reason for the high cost of these tickets, besides just operating cost, was that the original program was estimated to cost £70 million, but after a bunch of delays and overruns, the actual cost was £1.3 billion, which caused the program to be much smaller, so they didn't get as many planes out of it as they thought. So the per unit cost was pretty much impossible for the airlines to recoup. They also realized that supersonic flight was only viable for transoceanic routes. They couldn't have sonic boom over populated areas, so they had to limit it to transoceanic flights. And there's also a lot of widespread fear during this time. There was a pretty substantial crash in 2000 of a Concorde where, when it was taking off, something malfunctioned and all 100 people on board ended up dying. It's also discontinued right after the September 11th attacks, so there was a lot of fear towards the general aerospace industry, just in general.